We're doing a problem from page 55 in the textbook, looking at the number of protons, neutrons, and electrons in an atom. This time a little bit different. Our atom has a charge. So we're going to go through, look at this symbol, figure out what all the different pieces tell us, and use that to determine the number of protons, neutrons, and electrons. So the first piece we should see is this number up here, the 79. That is a mass number, and we should remember that the mass number gives us the mass of the atom, and the two particles that cause mass are the protons and the neutrons. So the mass number is equal to the sum of the protons plus the neutrons, so both things that are in the nucleus. Next thing that we can look at, that symbol Se, that tells us which atom we're dealing with, so we can use the periodic table, and we can find Se down here, and that tells us that it has an atomic number of 34. And remember, the atomic number is just equal to the number of protons. The last piece we've got up here is the charge, 2 negative. And what this tells us is it tells us the balance between the protons and the electrons. So let's start by writing out what's going on with the charges on the protons, neutrons, and electrons. We should remember that protons have a positive charge, neutrons have a neutral charge, and electrons have a negative charge. So that's why we write P with the plus, the N with the 0, and the E with the minus to show that protons have a positive charge, neutrons have a neutral charge, and electrons have a negative charge. So if I can see that overall I've got a 2 negative charge, the way I would have this is by having an imbalance between the number of protons and the number of electrons. You can never change the number of protons because the protons tell us which symbol we have, which substance we have. So in this case, we know for sure that we have 34 protons in here. I know that because Se on the periodic table has an atomic number of 34. So if it's got an atomic number of 34, and it's got 34 protons, how did it get a 2 minus charge? Well, it got that charge because it gained 2 electrons. So our 2 minus charge means 2 extra electrons. Again, because electrons have a negative charge. So if I had 34 protons and 34 electrons, my charge would be neutral. You wouldn't see anything there. But since my charge is 2 minus, I've got 2 extra electrons. So instead of 34, I've got 36. So again, that minus does not mean minus electrons. You need to think about what the charge on the electron is. If I have a negative charge, I have extra negative things, which means I've got extra electrons. Opposite to that, if I see a positive charge means that I am missing electrons. Remember that we can never change the number of protons because the number of protons is set. That is the atomic number of the substance. So the last thing we need to solve for is the number of neutrons. And again, we should remember that the mass number is equal to the protons plus the neutrons. So if we look, that mass number up there is 79. So that means that 79 is equal to the number of protons, which we know is 34, plus the number of neutrons. And if we solve that, we should be able to figure out that the number of neutrons in this substance is equal to 45. So again, protons comes from the atomic number. You can find that in the periodic table. Protons plus neutrons gives us the mass number, and comparing the protons to the electrons tells us the charge. In this case, 2 extra electrons because we have a 2 negative charge.